Thank you very much. Good morning, everybody. Let's continue our discussion in the area of the quality of service mechanisms used in broadband networks. We looked last time at the buffer management, and we saw the sharing strategies. We said that the buffer management, you can partition the buffer. You can do it this way. You have a single buffer, but you are going to partition it into multiple queues. It's a single buffer. It's a single buffer, but you are going to partition it in multiple queues, and the traffic will be what, for example, traffic that is available in the input slots will be destined to a particular output, will join a single queue. So they are not going to share the queues. Each one will go to their own queue. And we saw from the analysis, and we ended up with what? We ended up that each queue can look at a what? At a BDI or BD. Did we do this last time or not? I forgot. BD1K stands for what? Binomial arrival. Why is it binomial? Because we might have what? We might have multiple slots in here. All of them have packets, or some of them destined to this outgoing queue. Clear? To the Q1, for example. So we said that the probability there is an I arrival for the output one, for the first output, which means they will join a Q1, is N to N out of N inputs, choose I, P over N. P over N, P is the probability that there is a slot, and 1 over N is the probability that that packet is destined to that queue. We said assume that an arriving packet is equally likely to be destined to any one of these queues. So it's I times what? P over N to the I, 1 minus P over N to the N minus I. This is a binomial. So the model will become, for each queue, the model will become what? Binomial arrival, deterministic service. We are assumed that all the packets are of the same length. All the packets are of the same length. So deterministic service, what? 1, there is a single server. Each one of them is server 1. And then what? K is the size of the queue. Size of the queue. How many what? How many you handle. So this is the queue. Each one of them is like this, the size of the queue. And we already have discussed this. We talked about when we talked about the different types of models for the queues. Then we looked at what? We looked at shared memory. In this case here, we don't have, and the problem with this one, again, the problem with this one is that if this queue is empty, which means what? It means none of the packets in here are destined to the outgoing queue. This of the buffer will not be used. You follow me or not? It will not be used. So it's sitting there, but it's not used. This memory. In the shared memory, everybody is going to what? All of these packets are going to share this. So if there are no packets, destined to what? To this output, some other packets will be using what? Buffer here that are destined to somewhere else. Clear? It's a shared memory for all the packets. Clear? In this case, the arrivals, when we say the probability that there are I arrivals, we look at this equation and how it is different than this. This one is the probability of I arrivals or I packets destined to a particular queue. The probability that there are what? I arrivals. I don't care where are they destined to, because they are going to share memory. They are going to share the same memory. So the probability of I arrivals is what? Is times what? P of IP, again, is the probability that there is an arrival. There is a packet in a time slot times 1 N minus I. We went through the buffer occupancy equation, and we saw that we need because in here we are going to have what? Multiple departures. We have multiple departures from, we need to figure out what? How many of these, what percentage of these are going to come here, what percentage of these here, and so on and so forth. They are sharing the same buffer, but they are destined to multiple outputs. And we represented the buffer as a vector. For example, Q1 of N is what? Q1 of N is the number of what? Number of that are destined to the outgoing, to the first outgoing port, to this one. Again, sharing the same buffer. We ended up with a vector equation similar to the previous one, but instead of Y, we have now what? NK. Why NK? Because in here, what did we have? Any queues, each one of them is how big? K. In here, how many queues do we have? Just, we have a single queue, but what size? K, which is what? Equivalent to the previous one. So from the sizing point of view, the size of this memory is of the previous memory. Clear? Clear? The number QK means what? The number of packets that are destined to the outgoing port from 1 to n at the end of the n plus 1 time. N plus has to be less than or equal to what? Nk. It cannot exceed the size. And again, as I told you last time, there are some implementations for the buffer management that share of these two. In other words, they divide their memory into what? See this one here. They divide the memory into the first part, they implement what? Partitioned. The second part, they implement what? A shared structure. Part of the memory will be what? Shared, and part of the memory will be partitioned into multiple queues. And I think this is where we reach when we run out of time. So let's continue our discussion now. Now, buffer overflows. What will happen to the buffer overflow? When it happens to, remember, by the way, the buffer, if the aggregate incoming rate exceeds the what? The service rate. And the buffer will be to overflow. Then you need to worry about what? You need to worry about the dropping strategy. What is the drop? Now, one strategy is what? Is the tail drop. Tail drop means what? Tail drop means the thing lost will be dropped first. That's what it means by what? Tail drop. A front drop, the one that is in the front, will be what? Will be dropped quicker. The reason what? Can get a faster response from TCP. I need you to understand this. You remember, assuming of course you took it with me. I don't know if you took it, I don't know. But we will review TCP. In TCP, you start what? You start slowly and you build your rate. Are you following me? Aggressively. And then as soon as what? As soon as one timeout occur, what is that? That's an indication that the network became what? Congested. The network got congested, which means what? You need to drop your rate. This policy, if you drop that is ahead in the buffer, that will trigger a response from TCP than if you drop what? If you drop the last one. Because if you drop the last one, what does it mean? It means you first packets in the queue and the TCP at the sender will keep increasing his rate. Now the network is going to be what? Congested. But if you drop the first packet in the queue, that is a need to the TCP to what? To slow down before dumping more packets into the network. Clear? It will elicit from the TCP. The drop also could be chosen randomly. You chose randomly. These are based on a what? Based on a probabilistic method. He will choose packets to drop what? Randomly from the buffer. Full. But the one that I want to emphasize, because it's the one that is implemented in almost all currently from big companies like Cisco's or Juniper Networks or so on and so forth, is what is known as early detection or random early drop, RED. When they implement, also you can use what? WRED. WRED stands for what? The weighted RED. The same way as what? As FQ. We said FQ is what? Fair queuing, and there is fair queuing. Here again is what? Random early detection or what? Weighted random early. What is the basic idea behind this one? This is, by the way, is what is known as what? A technique for what? Congestion avoidance mechanism. One more time, the TCP. Review a little bit on TCP. Listen to me. In TCP, actually, called TCP a congestion avoidance method. TCP. Actually, TCP is sending packets at a higher rate. He is trying to force what? Congestion. TCP, which is running at the end system, is trying to force congestion to occur. Are you following me or you are losing me? In TCP, the sender is sending the rate. He is trying to force congestion to occur, and then he will what? Are you following me? He slowed down. He is trying to discover what? What is the point of a breakdown? Breakdown means what? The network anymore. Clear? If the network keep handling, TCP will keep what? Sending more. Clear? This one takes different approach. This approach here is to try to congestion before it occurs. Before it occurs. Oh, now, we discussed last time, let's see if you still remember, even though it's not in the chart. But let's see if you remember that. When the router feels, routers inside the network, they feel that they are getting what? They are being congested. One method they do is that when they are forwarding the packets to the destination, they will mark the header of the packet with one bit in what? Congestion is what? Is near. Think about it this way. Congestion is near. So when, listen to this, when the receiver receives those packets with the bit by what congestion is going to happen, when he acknowledge packet, one more time, is TCP connection oriented? Is TCP connection oriented protocol, which means what? It requires acknowledgement from the other side. Yes? You are not following me. Are you following me or not? You are not following me. Concentrate. That's the problem. How many of you took E? Okay, that's the problem. The other link here. Listen to me. TCP is a what? Is a connection-oriented protocol. We will review it. It's ended short. We will review it shortly. TCP is connection-oriented protocol. Every time the sender sends what? Segments to the receiver needs to what? Acknowledge it. And this. And if the acknowledgement get lost, the timeout will what? Will expire. There will what? Send again. Clear? In the first method of congestion, not this one, not the one that I'm describing to you right now. In a minute, I will describe it to you in a minute. The previous one, which is something to implicitly tell the sender that what? Sorry, explicitly that the congestion is going to happen. He does not tell the sender. He tells the what? The receiver is sending packets. The router feels that he is going to be what? Congested, that building up. What does he do? When the routers forward the packets, part of the header of the packet will be marked. There is a bit. One the packet, he put a what? A 1, for example. What does that mean? The router is telling the receiver, not the sender. The router is telling the receiver, I am getting what? I'm getting congestion. Clear? When the receiver receives those packets, he needs to what? Acknowledge. Because TCP is a what? Connection oriented that he needs to acknowledge. When he acknowledges it, he will echo it back. He will echo it back to the sender. In the acknowledgement in the acknowledgement packet, he will what? He will echo that bit. So that the network is getting what? It's getting very close to being congested. Get this or not? Not sure. Not sure. Okay, but in any case, if you do have me after the class. Did you get my point or not? What does the sender do? When he receives those acknowledgements, he needs to what? To slow down. Are you following or not? He needs to slow down. Actually, the sender will say what? What of the acknowledgements that he is receiving from the receiver has this bit marked? If that than 50%, that's an indication that the network is what? Is getting congested, which what? Needs to slow down. Clear? Clear? Okay. Now, let's look at this strategy called the RED strategy. RED stands for what? Random early detection. Sometimes they call it what? Random early drop. Based on. Let's understand what it's based on before we go to the chart. This is the buffer at the router. They define two thresholds. The minimum threshold and the maximum. Clear so far. Okay. And they do all of their analysis and anticipate congestion using an average queue size, not the actual queue size. Why? Why is it averaged? By the way, look at the equation. Equal to what? 1 minus alpha times what? The average length. Average length means is the what? This is the old one, this is the one. Plus what? Alpha times what? The sample length. Sample length means what? For this particular packet. Okay, now listen to me. Why they don't take the actual queue? Do you understand? Do you understand what do I mean by the buffer length? When we say queue average is what? The average queue size. Average queue size is what? Is the average number of packets. The average number of packets in the queue. My question to you is the following. First, why average queue size? Why don't they take the queue size? In other words, how many packets in the system? The average, because congestion in the internet, they change what? Drastically. For a time, the queue might become what? Heavy. followed by what? By a period of time that the queue is what? So if they take instantaneous queue length, that's not a good measure of question. Did you get my point or not? It's not a good measure that you look at the instantaneous queue length. You need to average it over what? Over a longer period of time. That's the problem, over a longer period of time rather than a what? A very short period of time. It's possible that for a short period of time, the the router is congested only for a short period of time, and then it's not congested. Is it possible? Would you say that the network is congested? Not say that the network is congested because it got congested only for a what? For a short period of time. But if over a long period of time, if you average it, then you have a better idea about what? About the occupancy. Clear? Okay, now let's get to this so that you understand it. This one, by the way, will be part of your project, the token bucket, which I will show you in just a second. So try to understand it carefully. Here. This is the buffer. By the way, the size of the queue, the size of your buffer, which means what? The size exceeds the maximum threshold. This is the what? The buffer size. Are you following me or not? So the minimum threshold and the maximum threshold. Clear? The minimum threshold and the maximum threshold. The buffer size, the actual buffer size, is longer than the maximum threshold. It's longer than the maximum threshold. And what is the algorithm tells you? It calculates the average length based on this running average equation. Standard or not? Yes or no? It calculates the what? The average length. If the average is less than the minimum threshold, then what? Accept all the what? Accept all the packets that are coming or not? Accept all the packets that are what? That are incoming. Queue them. Queue them. Do not. Did you get my point? Yes or no? If the what? If the average queue size is a greater threshold, if the average queue size is greater than the maximum threshold, hit with a probability of what? 1. Drop the packet with a probability of clear. Clear so far? Yes or no? Notice, by the way, when I say it's minimum threshold, does not necessarily mean that the buffer size is what? That the whole occupied. As long as it exceeds the maximum threshold, let's assume for the sake of argument, the whole size is what? 100. Yes? And the threshold, the maximum threshold is what? 80. It tells you what? To avoid congestion. To avoid congestion. As long as the average queue length exceed 80, drop the any incoming packet and do not what? Hold them. Even though there is a what? Even though there is a space, but drop them with a probability of what? 1. Average queue, if the average queue size, queue average, is anywhere between the minimum and the what? Maximum threshold, start dropping the packet with a probability of what? And get more aggressive as the size goes what? This size. Did you understand that or not? Notice, by the way, when I say drop the packets with P, what does it mean? Do not drop them with a probability of what? 1 minus. Did you get this or not? Did you get this or not? I need to show to you the diagram so that you understand what I'm talking. I want you to see this. If the average, this is the average queue, and this is the product. If the average queue is less than the minimum threshold, then what is the probability of dropping? Or not? If the average queue reaches the maximum threshold, the of dropping 1. You notice, by the way, it went directly from here to here. Why is that? Let's see why is that. By the way, some of the people who are not very comfortable feel that going from here to here should be smoother rather than what? Abruptly. The original RED, when they say this is an abrupt changes, their point of view is the following. The dropping probability is increasing. And this one is still going this way. In other words, when you drop when the probability of dropping, the size of the queue, the average size of the queue should go what? Should go down. Still going what? Up. Why? Why is it still going up? Because those packets did not have any effect on what? On the sources that are sending the packets, sending more packets. Did you get this or not? So they take a what? A drastic action. Meaning what? Is that once you reach, when the average queue reaches the maximum threshold, you will drop them with a probability of what? In other words, the policy of what? Dropping gradually is not what? It's not working. Be drastic and drop them with a probability of what? Clear? Oh, tell me, what does this line mean? What does this line means? This line. What does it mean? As the average queue is increasing above minimum threshold, the probability of it dropping is what? Increasing. The probability of it dropping until it reaches a maximum value, which is what? Pmax. If this one increases, the probability of it dropping will go all the way to what? Will go all the way to 1. Clear? Now, let's see. Clear? Let's see if you can understand. Now, the probability of dropping is what? Is some temporary probability, which I'll just a second, divided by what? 1 minus the count. I'll explain to you the count in times what? The probability of temp. So now what do we have here? Listen to me. I want you to look temp first. Temp means what? Temporary. This is temporary. We need this one temporary to calculate the probability of dropping. Can you zoom in please a little bit? I know, too much. Yeah. I will give you a numerical example in just a second. I want you, first of all, to understand the equations. It's not straightforward. I want you to look at Q average minus the threshold minimum divided by the maximum minus the what? Minimum threshold. Where is this? Forget about this. Tell me, where is this? Where is this one? Is what? Let's assume this is the what? This is the average Q. Yes? This. What does this mean? This divided by what? This. Did you understand what I just said or not? Yes or no? This Q average minus the minimum. Okay, an example so that you can see it clearly. Ready example. Okay, assume Q average is the minimum, middle value, middle point between a threshold, minimum and maximum, the midpoint. Yes, equal to. What is this term equal to? 1/2. Yes, assume Pmax is 1. This Pmax is what? 0.01. Clear? Question is what? Calculate the probability. Calculate the probability of dropping. Did you get my point? Yes or no? One more time. Average. Where is the average Q length? Is the middle point between what? The maximum threshold and the what? Which means what? That is the average Q length. Yes? What is this term? Average Q length threshold, which means what? This distance, divided by what? The maximum minus the what? The minimum, which is this distance. Are you following? Which is what? This distance from here to here. Yes? Okay. What is the P? What is the P temp equal to? Equal to what? 0.01, which is what? Which is this one. That's the P multiplied by what? 1/2, which means what? Point. Did you get this or not so far? Yes or no? Cannot hear you. Okay. Understand this equation carefully so that we can calculate the probability of dropping. The probability of dropping. What is it? Probability of what? The temporary probability, which we just calculated, divided by what? The count times what? The probability of what? Temporary. What does this mean? Listen to me. The count is the number of newly arriving packets that have been viewed, which means what? Not dropped. Do you understand what I just said? Those newly arrived, if they what? If they are not dropped, the count will what? Now, look, listen to me. If the count increases, happens to the probability of dropping. what will happen to the probability of dropping? The dropping will increase. Why? Why will it increase? Because the denominator will what? Let me show it to you. Let me show it to you. Okay, so now what is it? B drop equal to what? I'm using this equal. What is the P temp? Point divided by what? 1. Yes. The count times what? 0.005. Following me so far or not? Yes? No response. Yes? What is this equal? What is this equal to? 1 over 0.005 is what? Is 200. Yes? So what do I have? Minus what? Count. Yes? No response. You have simple math here. 0.005 is what? Is 1 over what? 200. So you get what? 200 minus count, and then the 200 comes in here, becomes what? 1. Yes? Count is equal to what? 1. What does that mean? If I say if count equal to 1, which means what? The arriving packets, the newly arrived, one of them was what? Queued. What is the probability of a dropping? Probability of a dropping will be what? 1 over what? 199. Now, okay. If the count equal to 100, what does 100 means? What does 100 means? 100 arriving packet were all what? Queued. Probability of a dropping will be what? 1 over what? Did it increase? Did it increase? Which means what? Chances are the packet afterwards, they will be what? Dropped with a higher what? With a higher probability. The chances of they are being dropped will be of what? A higher probability. Why? Because the count, which is the number of packets that were accepted, is what? Higher. The higher the number of what? The higher of the number accepted, the higher will be what? The probability of dropping for the new one that comes. Clear? Clear? So they manage it this way here. And the probability of dropping will keep increasing, will keep increasing until it reaches a point where what? Where the Q average approaches the maximum threshold, where this one will go directly to what? Will go directly to 1. Which means what? All to 1, what does it mean? It means all the packets that arrive will what? Will probability of what? 1. Again, why is that? Why is this one so drastic? This one is so drastic because this gradual drop of the packet, this gradual increase, probability of dropping the packet is not working means what? The average Q length keep what? Keep increasing. Did you understand? It keep increasing. Why is it keeping increasing? One more time. Why does it keep increasing? Increasing because the sources are not what? Slowing down. The sources are not slowing down. Clear? No response. Clear? No. And again, as I told you, I will ask you to simulate this this along with the couple of next algorithm that comes in the project. Did you understand it? Did you? One more time. Did you understand why do we deal with the average Q length instead of the initial length? Instantaneous Q length is not a good indication of the action that is going to happen in the network. Are you following or not? For any specific period of time, the average, the Q length might what? Might be high, but suddenly what? Everything is what? So you need to take it over what? You need to average it over a long period of time. Okay. Next, we need to understand what? We need to understand the policy mechanisms. Like this, operator. Thank you, sir. Can you zoom in, please? Thank you, sir. Mechanisms. Clear? Not policy. This is not policy. Policing mechanisms. What does this mean? Policing is the process of regulating the traffic or the rate at which is allowed to insert the packet into the network. Sources are not supposed to insert packets into the network at any rate they wish. Currently, this at any rate you wish. Currently. In other words, somebody tells you don't send the packets, or you just dump it on the internet. You just dump it on the internet currently. In the best effort model. In the best effort model, there is no what? There is no policing. Clarity of service model, we need what? We need some policing mechanism. We need some policing mechanism. We need to regulate traffic is what is entering the network. I want you to understand the criteria for the policing, which is long-term average rate and the short-term peak rate and the maximum burst size. Long-term average rate. You need to see interval of time over which the average rate is what? Is policed. I want you to see. I want you, if the average rate, 1,000 packets per second, and the other one is what? 6 packets per what? Per minute. Is this number the same as this number? Is this number the same? It is the same. This is what? 60,000 minute, whereas this one is what? 1,000 packets per what? Second. Is this number? It is the same. A minute is what? It's 60 seconds. Yes? But the question is what? You need to put the constraint. Are you going to be looking at a duration of 1 second or looking at a duration of what? 1 minute. Are you following me or not? When you are calculating the what? This one here is what is more strict. In here, when we say in 1 second, transmit more than what? 1,000 packets, is more strict than saying what? You cannot transmit more than what? 60,000. Because in 1 minute, you cannot transmit more 60,000. You could transmit more than what? 1,000. But then after that, you need to stop. The important, I'm not sure, did you understand the difference between this one and this one? In this one, and you cannot transmit more than what? 1,000. In here, in every minute, transmit more than what? 60,000. Yes? In here, does it mean you cannot transmit more than 1,000? No, it doesn't. You could what? You could in 1 second, you transmit 10,000, and then what? And then stay idle for some. Listen to this. I'm not sure you are getting all of these things digested to see this. This is 1 second. This is 1 second. Okay, and this is what? 0.2 second. 0.2 second. Yes? Listen to me. In here, you transmitted your packet in what? In 1 second at a rate kilobits per second. Which means what? In 1 second, how many bits did you send? 10,000. Yes? In here, in 0.2 straight can you transmit? With the same amount of bits. The same amount of bits. At what rate can you transmit? 50 kilobits per second. Did you get my point or not? It's 50. How much did you send? How much data did you send? 50 times what? It's 10 kilobits. Yes? 10 kilobits. In here, how much data did you send? Kilobits. But this one is what? In 1 second, you are transmitting what? 10 kilobits. In here, in point, transmitting what? 50 kilobits. Did you understand? Sorry, you are kilobits in only what? 0.2 second, transmitting at what rate? 50 kilobits per second. Did you get this or not? And that's what I meant by saying what? You need the time. When I say you means what? The network. The network who is policing your traffic. The interval of time in which the average rate is policed. For example, again, a constraint on the average rate of 1 second is not the same as what? 60,000 per what? Per minute. In a 60,000, in the 1 second, you can transmit more than what? 1,000. Are you following? The important thing is that what? In 6, you cannot transmit more than what? 60,000. Clear? So you need to specify the time. Are going to be calculating the average rate. Short-term peak rate, remember the peak rate. The peak rate is what packets you are transmitting in a what? in a very short period of time. That's very what is the smallest time between adjacent packets. Between adjacent packets, the smallest time. That's rate. And then the maximum burst size over a very short period of time. Over a very short period of time, how many what bits can you what can you transmit over in a burst? In one burst. What burst means at the same time, not what over some period of time. It's for a short period of time. You are going to send a what answer. Why? Because if you exceed the limit, what will happen to the queue? The queue will become what? Will become full. Clear? Okay. Mechanism that I will explain to you is two of them. The first one is called the leaky bucket. It's called the what? The leaky token bucket. Now both of these you must have had it in. Did you do? How many of you took CS402? Did you study those? Cannot hear you. Okay. It in CS, I think 570. Anybody took 570? Are you taking it this semester or previous? Oh, this semester. So maybe it's still coming. Okay, but in any case, and the leaky token bucket. Let's start with the leaky bucket first of all. This is the idea. There is a leak. There is a hole at the end of the bucket. So we have a bucket, and there is a hole at the end. There is a hole. Are you following or not? The incoming traffic are coming at what? Variable rate. Variable rate, not a constant rate. Did you understand that or not? But the dripping will be at what rate? The dripping will be at what rate? Constant bit rate or fixed bit rate. Did you get this or not? This or not? So the packets are coming at what? At a variable bit rate. They will join the queue, but when you put it on the at a what? At a fixed rate. This is called what? This is called the leaky bucket algorithm. So frames are received at the switch faster than they are transmitted will be what? Congested. And some frames will be disregarded. Let's see if you can help me with the example here. The leaky bucket algorithm. You set a counter. Of course, in reality, you don't have this. It's just an example. In reality, you are going to have an algorithm. Implemented where? Where is this implemented? This is implemented or the router. Are you following or not? You set some kind of a what? A time. Are you following or not? And you wait for the what? The clock tick. There is a clock. You are going to set a clock. You are going to. Is the size of the frame or the packet in front of the queue counter? What is the counter? Counter is the number of bits that you can what? Insert. The number of bits. If the size of the frame in front of the queue is less than or equal to the counter, then send the frame. Send the frame means what? Means you are still within the maximum limit. You have not exceeded the limit. So if the size of the frame in front of the queue less than or equal to the counter, send the frame. If no, you need to what? Reset the counter. Wait until the what? Until the next tick. Did you understand or not? Yes or no? No. When the click is here, the click is what? The clock is set. As the frames comes in, every time the frame or a packet comes in, what will happen is that this click will what? The counter will be what? Decremented. Are you decrementing? Let me show it to you a numerical example so that you understand what I'm talking about. The leaky bucket algorithm with an example. What did I say the count? What did I set the count to be? 10,000. When I say 10,000, what does it mean? It means I'm only going to allow to take what? 10,000 in a what? In a given time. The time is the what? Is the clock. Did you get this or not? The first frame. How long is it? How long is the first frame? 3,200. 10,000 will be accepted. How much is the count now? 6,800. Yes? Will it be accepted? This one will be accepted. How much is the count now? 3,400. Came how much? 800 bytes. Will this one be accepted? And this one will be accepted. Finally, what is the count? Came a frame which what size? 3,000 bytes. Will this one be accepted? This one will not. What does that mean? It means what? It means from here, remember, the clock is what? The clock is what? Is running. Did you get this or not? Which means what? It means that this one needs to wait until the next clock to come. Did you understand that or not? And the next clock comes, what will happen to the count? It will reset. Is that what I just said or not? No, you did not concentrate. Please help me. In one clock period, in one clock, am I allowing? I'm allowing 10,000. In every clock period, I am allowing what? In every clock period. Did you get this or not? Every time the frame comes, the count reduces. By the time it reaches 600, the next frame is how much? It's what? 3,000, which is more than the count. Yes? What will happen? What will happen? Not be accepted, will not enter. They are going to be what? Buffered. Until what? Until the next clock tick, where the number will be what? Where the count will be reset. Then you can what? You can transmit. So this is what? This is the second tick. In the second, am I sending? I'm sending this one, and I'm sending this one, and I'm sending what? That following me on now. These are the new arrivals. These needs to wait for what? Needs to wait for the... Did you get my point on that? Yes or no? Okay. So one more time to show. Of the frame at the front of the queue is less than or equal to the counter. One more time. Is the counter... The counter is decrementing. Every time a frame comes, the counter will what? Will decrement. If the size of the counter, then it's okay. Send it. And then what? And then what? Decrement the counter. But if the size of the frame is less than or equal to the counter, sorry, it's not the counter, no. Then you need to wait until what? Until what? Clock tick. Clear? Clear? Oh, good. Now, let's look at the token bucket. Let's look at the token bucket. What do I have? I have, this will be heavy in the midterm, so you need to understand it very carefully. I'll give you a numerical example in just a second. What do I have in here? What? A bucket. The tokens are generated. Tokens. See, the packets, this is the packets arriving into the what? Into the router. Are you following me on that? Will not what? Will not be served unless there are what? Tokens in the what? Did you get my point or not? Okay, now listen to me. The tokens are generated fixed rate, are tokens per what? Second. If this one is empty, what does that imply? If this one is empty, what does that imply? It implies that this one, a lot of these what? Tokens to transmit the packets, and the bucket is empty, waiting for new tokens to be what? Did you get this or not? When we see the bucket is empty, what is that an indication of? Light traffic. Heavy traffic. Are you following me? Heavy traffic. The packets came, the tokens, before what? Before new tokens are generated. When that happens, the packets needs to wait. Yes or no? Until what? Until you generate new tokens. Now, listen to me. What is the packet size? The packet size is the maximum packet size, which means the following. Listen to this, what it means. If the packet is full, what does it mean? How many tokens are there? B tokens. What does that imply? It implies that B, let's assume every packet requires one token. Requires what? One token. Clear? What does that mean? It means it can be transmitted very quickly. Do you understand it or not? In a very short what? In burst. And when they do that, what happens to the bucket? The bucket will, then what? Then you are going to be transmitting at what rate? At a what? Fixed rate. Are packets per what? Second. Why are packets per second? Because the tokens are generated at a rate of what? Are packets per second. Did you get my point or not? I'm not sure. Let me see if you got the equation. I want you to look at the equation. This, first of all, the leaky bucket, leaky token bucket depth is what? Is B tokens. Yes? B tokens. Tokens are generated at a rate of what? R tokens per second. They are added to the bucket. Bucket is full. If the bucket is full, are what? Generated. Those tokens are what? Discarded. Did you understand that or not? No. If the bucket is full and the tokens are generated, what does that tell you about the traffic or no traffic? There is no traffic. Did you understand that or not? No traffic resulted in the bucket heavy, full, and the tokens are still what? Being generated. Those tokens what? Discarded. Clear? No response. Clear? Now, an arriving packet needs to be before what? Transmission. If the packet is what? If the packet is what? If the packet is what? Empty. Oh, empty. Correct this one. If the packet is empty, tell me what happens. A packet must wait. Yes? Wait for what? What is he waiting for? For new token. Or, depending on the implementation of the policy, depending on the implementation, the router might what? Drop the packet. Do you understand that or not? He might drop the packet. What? Allow the packet even to wait. Why? What does that mean? One more time. What does that mean? It becomes what? Empty. It means the source is sending what? Is sending too many what? Too many packets at a higher rate. Higher than the what? Higher rate than the rate at or what? Generated. Yes or no? He needs to be what? That source needs to be what? Penalty for this. The penalty is what? His packets are either going to what? Wait or what? Dropped from the buffer. Clear? Dropped from the buffer. This is the point that what do I mean by this? The maximum burst size. Remember, when we talk about a burst for a short period of time, the maximum burst size allowed is B. Why? Can you tell me why is it B? That's the size of the packet. Yeah. If it is full, you can transmit how many packets? B packets, very short period of time. What will happen to the packet afterward? Empty, because you have used all of explain this equation for me. The maximum number of packets entering the network over arbitrary time T, over any arbitrary time T, is how much? RT what? B. Why? Can you tell me why is it RT plus B? This will enter at a what? At a very short period of time. Yes? Yes? Over a period of time T, capital T, how many packets can you send? You can send RT. So a T plus what? Plus B. Clear? Not sure. And it will be in the midterm, so I need to make it clear to you. Can we concentrate? The maximum entering the network over an arbitrary time, what? T, capital T. Over a very short period of time, almost equal to what? 0. How many you can transmit? And the what? And over the capital T period, how many extra packets you can transmit what? R times what? T, where R is the rate at which the tokens are generated. Clear? I want to show you something. I'm not sure. Let's look at the numerical example so that you understand what I'm talking about. Leaky token. Let's assume that we do have two flows, A and A. This is what? Let's say this is 3 seconds. Just an example. In a 3-second interval, A is generating of what? 1 megabyte per second. 1 megabyte. Are you following me on that? Yes or no? Is it constant? For flow A, he is generating how many bytes? 1 megabyte per second. Clear so far. Flow B, this is flow A. For flow B, for the first 2 seconds, he is generating at a rate of what? 0.5 megabyte per second. And then, for the next second, he is generating at what rate? 2 megabytes per second. This is B. And answer me the following question. In a 3-second interval, are they sending this of bytes? In a 3-second interval, are they same amount of bytes? Yes, they are. but one of them at a rate of what? 1 megabyte per second, where constant the other is what? Is sending at a rate of what? 0.5 megabytes per second for the first 2 seconds, what? 2 megabytes per second in a what? In the remaining interval. Wait. Yes or no? Okay. Now, tokens are generated at a rate of 1 megabyte per second. Okay. Now, and assume every requires a token. Every byte requires a what? A token. Yes? Okay. This is flow A. And this is what? This is the token for flow A. And this is flow B. Each one have their own bucket. B1, B2. Clear? Tell me what is B1 should be. What should B1 be? What is the depth of this bucket? What is of this bucket? Flow A is generating at what? 1 megabyte per second, and the tokens are being generated at what rate? 1 megabyte per second. Yes or no? What is the depth? Bytes should there be? How many bytes should there be in here? What is the size? In other words, how many tokens should there be here? Remember, every byte requires 1 token. The A is generating traffic at a rate of what? 1 megabyte per second. Yes? The tokens are generated at a rate of what? Megabyte per second. What is the depth? How many bytes? Remember, it means what? 1 token. So when I say how many bytes, it means what? How many tokens? The size. The size should be only what? You didn't get it. Get it. Why is that? Listen to me. The arrival is at what rate? Byte per what? Second. The tokens are generated at what rate? 1 megabyte per what? Second. Which means what per what? Second. When they are generated, the packet will be what? Pick it up and move. In other words, will they? They will not pile up. So all what I need is a size for 1 token. Did you get it or not? Yes. I don't want this bucket to what? To go overboard. Traffic is arriving at what? 1 megabyte per second. The tokens are being generated at a rate of what? 1 token per second. Yes or no? Each byte requires what? 1 token. So generating the token, this one will what? Pick it up. Next one. Pick it up. Pick it up. Pick it up. Yes? How much size do I need here? Just 1. No, there is no 0. Go somewhere. You don't say 0. 0 means what? Means, by the way, the token is not synchronized with the arrivals. Do you agree? Did you agree or this on? Are these synchronized? When the tokens are generated, are they synchronized with? No, they are not synchronized. They have the same rate, but they are not synchronized. Not sure. Did you get this? Did you get this or not? Are they 1 megabyte per second, and the tokens is what? Generated at what rate? 1 mega. Are they of the same rate? But do they need to be synchronized? They are not going to be. Need to hold how many tokens? Just 1 token. Why? We'll pick it up. Tell me this one. What should B2 be? What should this size? Now, what is he using? 0.5 megabyte per second. Yes? 20 second for 2 seconds. Yes? And the token at what rate? 1 megabyte per second. which means he is using, first 2 seconds, he is using half the tokens that are what? Generated. Yeah? What happens to the other half? What happened to the other half? They need to stay in here for what? Waiting for this interval between 2 to 3 where he is going to use rate he is sending 2 megabits per second, where he is going to use is already in there, and then what? The new generations of the token. How much should it? This should be 1 mega. Or not. This should be what? 1 megabyte. 1 megabyte means what? Or 1 mega token. Did you answer where this 1 mega came from? Yes, why? Where did it come from? The rate is at what rate he is generating the tokens? 1 megabyte. Of course, is sending at what rate? 0.5 mega. Which every second, how much is he saving? How much is he not using? 0.5 mega. 2 seconds, how much he is not using? 1 mega. That should be enough to what? The depth, the token of what? 1 mega. Now, and during this time, what will happen? He is a transmitter. 2 megabytes per second. What is he going to do? He is going to use, that's how much? 1 megabyte. Yes or no? And then what does he do for the other megabyte? He's going to what? Use the new. By the way, is he going to save anything? Is he going to save anything? He's not going to save anything. He is using this. Will he start saving again? He will start saving again at this time, because he is going transmitting at what rate? 0.5 megabytes per second. Clear? Clear? That's the leaky token bucket. Okay. Now, the leaky token bucket, the what? With the weighted fair queuing. With the weighted fair queuing. Let's understand this very carefully. For what? For guaranteed on the maximum delay possible. These are the flows. Remember, in weighted fair queue, what? Every flow has its own what? Buffer. These are the what? Buffers. Before you, the packets will go through what? A leaky token bucket. Listen to me. Why? Because if they keep what? Sending packets at a higher rate than the air, what happens to this buffer? Will begin to pile. Did you understand that or not? The router is policing the arrivals. Tell me in here. The packets are coming in here. What is the maximum delay? Can you tell me what is the maximum delay encounter? Now let's assume this one has a weight of W all the way to what? WN. This is weighted fair queuing. Yes? And the capacity of the router, this is C. Explain this one to me. Why is the maximum delay B1 the size of the packet? B1 over what? C times W1 by what? The summation of what? WK. Can you zoom in please a little bit? More. Yeah, very good. Thank you, sir. Can you explain this equation for me? Maximum delay here. Who is going to encounter the maximum delay? Who? The packet at the end. The packet at the end. How many packets can go there in a very short period of time? B. Yes? So how many packets are there? B1. How much share is each one getting? Is this buffer getting? Is C times what? W1 over WK. Did you understand this part? By the way, when I say summation of WK, the summation is over only the active what? Flow. You see my broadcast yesterday? I sent the broadcast. No, you did not receive it yet. You don't check. Did you receive it? I gave you this equation. Did you get my point or not? Yes or no? This is only the what? The active weights. Still, I'm not sure if it's that. Why is that? And provided R1 is less than CW1 times what? Divide by some. Okay. Concentrate, please. Listen to me. Listen to me. Short period of time. If this bucket is full, how many of these can be one over a short period of time? Yes? Which means, remember, every packet requires how many tokens? 1 token. Yes? So B1, how many packets will there be? B1. What is the maximum delay? The maximum delay is the one that is what? At the end. Yes or no? What is it? It's what? B1, which is the size. Yes? Divided by the rate. Yes or no? What is the rate? The rate is what? C times W summation WK. Did you understand this equation? The first equation. That's the maximum delay. Is that a guaranteed on the delay? That is a guaranteed on the delay. He is not giving you what will the delay be. He tells you the delay is this value. Clear? Why is this? Y is less than CW1 divided by summation of WK. If the rate at which the generated exceed the what? Your share of the capacity. What does it gives the user the ability to what? Send more packets. Yes or no? And more packets, will the delay increase or decrease? Increase. I'm struggling here because I'm not able to get through. I need to be able to get through you. Throughput. Concentrate. Concentrate. Over a short period of time, how many packets does this B1? Assuming the token bucket is what? Full. Those packets, how many packets are there in the one? Yes? What is the maximum delay? The maximum delay is what? Is B1 divided of the rate. Did you get this or not? Okay. Why I say provided that R1 is less than? Because if R1 is greater than this value, is greater than your share of the capacity, what happens? There will be more packet coming what? In. Yes? Which means no longer what? B1. It's more than B1. Yes or no? It was what? RT. Yes or no? Where T is a given interval of time. Yes? They will go what? Higher or lower? Higher. Eventually, what will happen? Eventually, some will be dropped. Are you following me or not? Eventually, they will be dropped. Now, who decides these and B1? Who decides them? The router decides them based on the agreement that was the customer and the what? Service provider. They will assign these such that they will give lead on what is your maximum what? What is your maximum delay? Did you get this? Did you get this or not? Yes or no? Okay. And again, this one you will, can you zoom back please? Will be asked to simulate. I will assign the project soon. Clear? This is the way it is done. This is in the routers. They do have what? The first, when, by the way, where are these? Are these in the core or at the edges? At the core, not in the core. At the edges, they monitor the traffic coming from each what? By creating two parameters. What are the two parameters? The rate, where the rated, this is used for what? Over longer period of time, T, and what? Setting up some size of the packet to determine what? What is the maximum burst size means what? Over a short period of time, how many packets can you what? Can you transmit? Did you get to make sure that you do have enough what? Enough tokens in here to allow you to transmit a burst over. Clear? Oh, now the traffic shaping. This is the policing. Now it's a shape. Is what? Mechanism to make the traffic smoother. Now listen to me. From the network point of view, to be smoother or bursty? They would like it to be what? Smoother. Are you following on now? So we have an application generating at 10 kilobits per second periodically. The source can transmit many ways. One way to send it is what? Is that in 1 second he is going to send how many bits? 10 kilobits is what? In 0.2 seconds he is sending what? He is sending it at rate of what? Per second. Did you get this or not? Yeah. Did you get it or not? So from the user point, he can send it this way or he can send it this way. Is it the same amount of data? The network of you, which one does he like better? From the network. Does he prefer this one or this one? He prefers he do. When it's supposed, by the way, from the customer point of view, which one he prefers? Which one he prefers? This one. Oh, now you might say, why? He is sending his data at a what? Same amount of data over a short period of time. Are you following me or not? Rather than actually sending. Think about this way. You are working what? 0.2 seconds, and the remaining of the time you are taking a rest. This or not? From a customer point of view, you would like it this way rather than this way. Let's see if you can help. The leaky bucket, traffic shaper. The leaky bucket, traffic shaper. The traffic is at what rate? Variable bit rate or fixed bit rate? Bit rate. Yes, but the outgoing is at what rate? At what rate the outgoing? Is this variable bit rate or fixed bit rate? This one. Bit rate. Why is it variable? During this time it's what? 50 kilobits per second. During this time is how much? 0. Is this fixed bit rate or variable bit rate? Fixed bit rate. Let's see the leaky bucket. And remember, the network preferred user is sending it this way. So he is sending this. The router is generating the traffic at a what? Did you get this or not? Yes or no? What is the problem with this one? Can you tell me what is the problem? The problem with this one is that the router is penalizing the traffic that is what? Conforming means what? I need you to understand. Let's look at this. Incoming packet stored in the buffer. It's constant when the buffer is wet. It's not empty. When the buffer is not empty, the outgoing rate is what? It's constant. The buffer size, the maximum burst. We already know that. If the buffer is full, the packets are in what? Violation. Be what? Discarded. If this buffer is full. Clear? The leaky bucket traffic regulates. It regulates the traffic, not only what? Monitor the traffic, but it regulates amount of what? Traffic coming in. Let me ask a question. If you do have a bucket with a hole in the middle, not in the middle, at the end, and you keep pouring water into the bucket, there is a hole at the end of the bucket where from the bucket, and you keep pouring water into the bucket, will the bucket overflow? When I ask a question, I expect a response from you when I feel so depressed. Concentrate. I have a bucket with a hole at the end, dripping at a what? Constant rate. You keep pouring water into the bucket. Eventually, will the bucket over? What will happen to the extra water? Will be dropped. Even though there is a hole, because the hole, you are going to what? Drip the packet at a what? Constant rate. Yes or no? Now, if the bucket is not full, you are dropping the water, but full. Is the output at a constant? Yes, it is at a constant bit rate. But did you punish that user? You punish that user. Why? Why user? That user did not put what? Packets more than, did not cause the packet to what? To overflow. I struggle with you guys so much. Give me one more minute, please. I need to make sure they got the point. Did you get the point? I'm putting water into the bucket such that you overflow, you violate the agreement. I punish. But if you put water into the bucket such that the bucket is wet, not overflow, still punishing you. I am still punishing you. Why? Because you would like your traffic to be what? Variable bit rate, but at a what? Constant bit rate. Clear? Because of the hole at the end of the bucket. See you next time.